So today we're going to talk about the last of our quadrilaterals. We talked about polygons, and then we talked about specifically four-sided figures. And then within that, we talked about parallelograms that have two pairs of parallel sides, kites that have no pairs of parallel sides. And today we're going to talk about trapezoids that have one pair of parallel sides. So we have two different kinds of trapezoids. The trapezoids, we have one pair of parallel sides. Now, here's what's important about that. We only have one pair, and that one pair, what that creates is consecutive interior. We have the same thing, right? Our consecutive interior, but it is for the angles that are between the parallel lines. So what I mean by that is that these two are consecutive interior, and these two are consecutive interior, which means the two red ones add together to equal 180. The purple ones add together to equal 180. But here's the mistake that students make is like a parallelogram. They think that all of them do. These do not equal 180, nor do these, okay? Because they are not between the parallel sides. So they do not equal 180. So make sure you don't make that mistake. Now, if I were to take an isosceles triangle and just cut off the top of it, then what I'm left with is an isosceles trapezoid. So what makes an isosceles trapezoid is when you have two legs, which are the non-parallel sides, that are congruent. So we have these two that are not parallel, that are congruent to each other. What that forces to happen is that these diagonals now are the same length. Okay. What also happens is just like with an isosceles triangle, your base angles are the same. So I've got this whole angle, that base angle is congruent to that base angle, but I also have this other set of angles. These are also base angles, and these two angles are congruent to each other. Okay, so your base angles are congruent, and then your opposite angles are supplementary. Now, the reason that's not so important to remember, because we already know that a blue plus a red equals 180. So now it doesn't matter which blue one you use or which red one you use, so you can use your opposite angle. So that's just, it's a handy little tool to have, but it's not necessarily one that you have to remember if you remember that your consecutive angles between the parallel lines are already supplementary. Okay, so let's look at some examples with this. So we've got this regular old trapezoid, not isosceles, and so we want to find angle K and angle M. And so here's where you have to be careful again. Angle K, to find angle K, you're going to use the 51, not the 87. The mistake a lot of students make, like I said, is they want to do the ones on top together. Okay, those do not equal 180 because this angle and this angle at K, those are not between parallel lines. That parallel line is the transversal. So you don't want to use that. What we want to use is the angles between JK and ML. So you would take 180 and subtract 51, and you get that angle K is 129 degrees. Okay, so then you can have, from there you can use, find angle M two different ways. You can use these consecutive interior angles. So we have 180 minus 87, and we get that angle M is 93. Or if you were to add all four of those angles up, you would find that they add up to 360, which is what all the interior angles of a quadrilateral should add up to anyway. So that is another way you could have found that 93, was to add up the 87, the 129, and the 51 and subtract that from 360. Okay, so number 3, same line of thinking. We have our parallel sides, and then we have our transversal. Both of these angles are along that transversal, which means they are consecutive interior, and we know that consecutive interior add up to 180. They're supplementary. So if I take 54 and I add 8x plus 6, I can set that equal to 180. Then I can solve. So I have 8x plus 60 is equal to 180. Subtract 60 from both sides and get 8x is 120, or x is equal to 15 when you divide both sides by 8. Okay, so that has to do with my angles. So DEFG is an isosceles trapezoid. Notice that we go in order DEFG, like as though you're walking around the shape, right? DEFG is an isosceles trapezoid. So what I'm asking, because it's congruent, I'm asking for side lengths, not number measurements. So DG would be congruent to which other side? Well, DG is the leg, and EF is the leg, so DG would be congruent to segment EF. And DF, which is a diagonal, would be congruent to EG because the diagonals are congruent for an isosceles trapezoid. So we would say segment EG. So for number 7, we're back to talking about the angles again. Again, almost always when you're talking about the angles for a trapezoid, you're going to use that consecutive interior. So what I know is that I'm probably going to need this. I haven't even looked to see what I'm being asked for, but I know that that angle is going to be 68. So it's asking for angle Q. Well, angle Q would also be 112 because it is isosceles. I know that it's isosceles because of the markings, so watch for that. But that means your base angles are congruent. So this angle is 112. Then angle R is supplementary to angle P and angle Q. So it would be 68, and it's also equal to angle S, which we already found in advance. Okay, so notice where those angles are and how they relate to each other. So number 9. Number 9 says MNOP is an isosceles trapezoid. As soon as you read that, go in and mark what that means. MP is 16x minus 13. NO is 9x plus 8. PN is 5y plus 19, and MO is 12y minus 37. Solve for x and y. So good thing is both of our variables are in the right places to do this in 2 separate pieces. So I know that my sides have to be equal to each other. So 16x minus 13 is equal to 9x plus 8. So just solve for x. So I'm going to move my 9 over to the left and move my 13 over to the right. So I'm going to subtract 9 and add 13. So 7x is equal to 21, or x is equal to 3. So there's my x. And then my y, my diagonals are congruent to each other because this is an isosceles trapezoid. So 5y plus 19 is equal to 12y minus 37. Okay, now this time I'm going to move my y to the right. I always move my smaller one over to where the bigger number is. And I'm going to move the 37 over. So I'm going to subtract 5y from both sides and add 37 to both sides. So I get 7y, and 19 and 37 is 56. Divide both sides by 7 and you get that y is 8. Okay. Let's skip down and do number 11. Number 11 says if JKLM is an isosceles trapezoid, again, I always mark that first thing so I can remember what that means. Find each missing angle. So again, we're talking about our angles, and most of the time our angles when we're dealing with trapezoids are supplementary. Sometimes if it's an isosceles, it could be base angles, but these are not the same base angles. So M would be congruent to L and J would be congruent to K, but J and M are supplementary. So we know that angle J plus angle M is equal to 180. So you would say J, which is 10x minus 33, plus M, which is 4x plus 17, is equal to 180. So let's simplify the left side, combine our like terms. So 10x and 4x is 14x. Negative 33 plus 17 is negative 16. So that equals 180. Add 16 to both sides. You get 196, so 14x is equal to 196. Divide both sides by 14, and you get that x is equal to 14. And it says to find each missing angle. So now that we know what x is, we can say, okay, well, 4 times 14 plus 17. So 4 times 14 plus 17 is 73. So that means this angle is 73. That means this angle is 73. And then we can do 10 times 14, which is 140, minus 33 is 107. And then this angle is 107. So all of our angles have been found, and those are all in degrees. Okay, then we have 13. 13 works similarly, except in this case, it's isosceles, so we mark that it's isosceles, and these two angles are not consecutive interior. They are consecutive, but they're not consecutive interior along between two parallel sides. So these two angles, they're base angles, these two equal each other. So you notice the difference between the two, because these two are up here and those two are definitely not supplementary. Okay, so the consecutive interior is supplementary, and those are the ones that are between the parallel sides. So these two we know are equal. So we say 21x minus 16 is equal to 18x plus 5. So I'm going to move my 18x over by subtracting it. I'm going to move my 16 over by adding it. So I get 3x, 21 minus 18 is 3, 5 plus 16 is 21, so I get that x is equal to 7. Now it says to find each missing angle, so I go back, it doesn't matter which one, 18 times 7 plus 5, so 18 times 7 plus 5 is 131. It doesn't matter which one you go to because this one is the same thing. And then we want to know F and E. Well, back to what we talked about before, F and E, those are consecutive interior with D, so, and C. We also know that the opposite angles are supplementary in the case of an isosceles trapezoid, and only isosceles trapezoid. That's why I want you to be really careful with that. So we could take 180 then and subtract 131, and we get 49. So this angle is 49 and this angle is 49 because the base angles of an isosceles trapezoid are congruent to each other. So we've got those things. You can see kind of what kept coming up. Obviously, base angles being congruent is important. The diagonals being congruent is important. And the consecutive angles between the parallel lines are supplementary. Those are the things that just keep coming up over and over in every problem, and you want to make sure you remember